All right, I thought I'd go over the homework on arithmetic sequences and series and just do each problem. I know that the most common question that seems to come up is about the notation, like what is n, what is u sub n, all that kind of stuff. So this is a sequence right here, right? This one's actually geometric, but it doesn't really matter. The notation works the same either way. So this is the form. This is u sub n. This would be the sequence, right? And so n refers to the place order of the term. Like this is the first term, second term, third, fourth, fifth, sixth, and so on, right? So u sub 1 is going to be 4, and u sub 4 is 32, and u sub 6 is 128. So if you see something that says u sub 8 equals, I don't know, 94 or something, like a different sequence, then that means that the 8th term, so 1, 2, 3, 4, 5, 6, 7, 8, the 8th term is what they're referring to. It tells you that it would actually be 94. So it would be a different sequence, but that's what that's talking about right there. So here n would be 8, and the 8th term would be 94. All right, so let's get into it here. Let's find the sum of the first 20 let's find the sum of the first 20 terms of the arithmetic sequence 5, 9, and 13. Okay, so I got my formulas down here, right? We could do it a couple ways. We could use either one. I prefer to use this one whenever I can. But on this example, it would actually take a little more work because I can just look right here and see that D is 4. So I know what D is. I know what N is because it's the first 20 terms. We're going to be finding S sub 20. So, and I've got U1 right here. That's the first one. So I'm going to go 20 over 2. That's, of course, 10. I always forget to write this 2 right there, so I got to be careful. Plus 20 minus 1 times the common difference, which we said was 4. Right? So all we got to do is just simplify this. When you do all that math, you're going to get 10 times 10 plus 19 times 4. You can plug that into a calculator. You're going to get 860. Right? All right, let's talk about the second one now. We've got an arithmetic series. It's got a first term of 7, so I know U1 is 7, and a common difference of 3, and we've got to find the sum of the first 50 terms. So once again, this is going to be the easier formula to use because I don't know what the last term, which for this case would be U sub 50, I don't know what that equals. Here it doesn't give me that information. So I'm going to do S 50, the sum of the first 50, so that's going to be 50 over 2. And then 2 times the first one, which is 7, plus n minus 1. N is 50, so minus 1 is going to be 49 times the common difference, 3. And if you do all that math right there, it's going to be 25 times 14 plus, what is that, 147, I think. Anyway, plug it into a calculator. I did it a little earlier. It's 4,025. All right, on and on to the next one. So that's 1 and 2. Here's number 3. It says the sum of the first 30 terms of an arithmetic series is 2,370. The first term, so first of all, I know n is 30. I know u1 is 10. The first term is 10, and here we have to find the common difference. All right, so that's our clue, because the hardest thing to do is to figure out which formula to use. This one says find the common difference, so once again, we're using this hotness. So the sum of the first 30 terms. So I know that S30 is going to be 30 over 2 times, I almost forgot the 2, 2 times 10 plus 29 times D. You see? And I know this is 2370. So 2370 equals 15 times 20 plus 29D. So divide both sides by 15, right? I don't know off the top of my head what that equals, so I'm just going to leave it like this. And then in here, look what we've got. We've got 20 plus 29D, so I can subtract 20. So I'm just going to put minus 20 right here equals 29D. And then just divide both sides by 29, and you're going to get it. you're going to get D equals 4.76. So in case you don't believe me, let's get the calculator out right here. Let's see, can we see that display? I think so. Let's clear that hotness. 2370 divided, see, 2370 divided by 15 equals minus 20 equals divided by 29 equals 4.76, rounding to the three significant figures, so the first three non-zero numbers. All right. Number 4. Okay, number 4 says find the 15th term in the sum. Oh, and the sum of the first 15 terms. So we have to find U15. We also have to find S15. So this one kind of tells me that we're going to be using this formula because we have to find this anyway. And this is what we have. So even though we're doing series, we got to use the sequence stuff right here. This is the sequence formula right here. We have to use that in order to find U15. So first thing I'm going to do is look for D. The common difference is negative 6. I have no idea why I said 9. All right. So U sub n. So U sub 15 is going to be U sub 1, which is 82. The first one is the U sub 1, 82. Plus n minus 1. So n is, of course, 15, right? So 15 minus 1 is 14 times d, right? Oh, and d is negative 6. So I'm just going to go ahead and write negative 6 right there. So where'd my calculator go? Because my brain is not braining anymore. Been a long day. Let's see where we can put this so you can see. So we got 14 times 6. Got to remember that's negative, right? Oh, so negative 2. So U15 is equal to negative 2 because this is negative 84, right? Okay, so now that we've got U1 is 82 and U15, right? U15 is negative 2, so S15 is going to be 15 over 2 times the sum of the first and the last, so 82 minus 2. So that's going to be 40 times 15, right? Because this is 80. Half of 80 is 40. So 600, I think. Yeah, 600. All right, on to the next one. The 10th term of an arithmetic sequence is 45. So U10 is 45. Do you see how as I'm reading it, I'm making some sense of it too? And the 20th term is 95. And we have to find the sum of the first 20 terms. Okay, this one's similar to the last. Either formula for sum, you need U1 and we don't have it. It doesn't tell us to find it, but we're going to have to, right? And since we're finding the sum of the first 20 terms, and we know the 20th term, we know UN. We know that's 95. So let's use this information with the sequence formula to find U1. Let's use U10. So U10 is going to be equal to U1 plus, let's see, n minus 1, so 10, so 9 times d. Actually, take that back. That won't work. That was an honest mistake. Here's what we got to do. I was getting a little silly. We're going to have to find d before we can find u1. So let's do this right here. Let's do u20 equals u1 plus n minus 1 times d, right? So, u10. So u20, 95 equals 45 plus, now if I go from 10 to 20, that's actually 11. So n here is going to be 11, and if I subtract 1, I get 10, right? So subtract, and you can see that d is 5. Okay, so now we can do what I was going to try right there. We can say, what we're going to do is we're going to do u10 equals u1 plus n minus 1 times d, that stuff, right? So 45 equals u1 plus, let's see, it's 10, so 10 minus 1 is 9 times 5. So 0 is u1, because this is 45, subtract it, right? So now we can use this formula. We have to do S20. So S20 is going to be equal to 20 over 2, which is 10. and then 0 plus 45. So 450 is our answer. All right, so that was an honest mistake when I started here, and those kinds of things happen all the time. So I didn't plan it, but I'm actually glad that it did happen, because as you're working through things, you're not sure if you're right, and you have to pay attention to what you're doing and if you're getting what you need. And if you don't have enough stuff to work with, then you might have made a mistake and you need to back up a little bit. That's what happened to me right there. All right, number 6. An arithmetic series has a common difference of -4. The first term is 60. How many terms have to be added until we get to 0? This is a tricky one right here. So check this out. We know that D is -4, and we know the first term is 60, and we don't know N, right? So, but we do know we want to figure out what is N when the sum is 0. So knowing D and the first term means I can't use this formula because I don't know UN, so I have to use this one right here. So here's what I'm going to do. I'm going to go ahead and plug in what I know here. So I'm looking for at what value of N does the sum equal 0? So N over 2, I don't know what N is. 2 times U1, so 60. That's going to make 120 there. Plus, I don't know what N is. I do know the common difference is -4. Sorry about that little mistake right there. So we have to solve this. Right away, we could multiply both sides by N over 2 because it's equal to 0 over here, and it would just go away. Or by 2 over N, the reciprocal, right? Because this whole thing right here is all being multiplied. This whole thing is being multiplied by that. So if I multiply both sides by 2 over N, these two things would cancel, and if I multiply this by 2 over N, then that's just 0. So 120, right? 120. And then I'm going to go ahead and distribute this because I have to solve for N. So -4N plus 4, right? So this is 124, so I'm going to subtract 124 from both sides, right? And it looks like 31. So at the 31st term, the sum would be 0. So S of 31 is going to be 0. All right, moving on. Number 7. Oh man, we got some trickiness right here. Check this out. We've got sigma notation, our good old friend sigma notation. All right, so it says evaluate 1 to 25. So this is the same as saying S25. We're starting on 1, going to 25. We can use either one of these. I actually think this one's going to be easier here, but either way, we have to find two pieces of information. We have to find U1 and D. The reason I think this is easier is because that coefficient is the common difference, right? And to find U1, all I got to do is plug in 1. So U1 is 5, right? You see, U1 is 5. So D is 3, U1 is 5. So let's do this. We're going to do 25. So S25, 25 over 2. 2 times 5 plus N minus 1. So N is 25, minus 1 is 24, times D, which is 3, right? So whatever this turns out to be, that's what we're gonna have. Let's see. We'll get our calculator out here. So 10. Let's see. Can you see it there? Yeah, there you go. So 10 plus 24 times 3 equals, divided by 2 equals, times 25 equals 1025. How's that? Not too bad, right? 1025. All right. Oh, next one right here. That was number 7. This is number 8. That's number 7, number 8. Okay. So this one's a little trickier. I'd like you to notice we're not starting at 1. We're starting at 0. So our first term is actually, we're going to plug in a 0 right here. But let's read the instructions. Find the first and last terms of this series. So we have to find U1 and we have to find the last one. It's actually going to be 10. I'll explain why in a second. And then we have to find the sum of the first 10 terms. The reason I know it's 10 is we're starting plugging in 0 and we're going all the way up to 9. So if you go to 0 to 9, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. If you look, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. You see that? So that's why we're going to use that right there. So to find U1, all you got to do is plug in 0 right here because we're starting at 0. So U1 is 12. And to find the last term, we're going to plug in 9. So we're going to get negative 6 because 12 minus 2 times 9, right? That's 18. 12 minus 18, negative 6. So in this case, this formula is super easy. So S10, because we're using 10 terms. So 10 divided by 2, right, is 5. And then U1 was 12 minus 6. So that looks like 30 to me, right? 12 minus 6 is 6. 6 times 5, 30. All right. Killing it. Okay, next one, number 9. All right, this one's kind of weird too. A lot of people freak out because they see I, but I in this situation, I is not the square root of negative 1. It's just a placeholder like n is. It could be k. Sometimes you'll see r. You'll see all kinds of different letters there. You don't have to really worry about that. So it says we have an arithmetic series, and it's written in this, and we have to find the value of n. Oh, that's kind of weird, right? So this is what this is really saying. If we translate this, this is saying the sum of the first n terms is 663. All right? So we can use either one of these formulas. Well, we actually can't. We don't know what n is, so we can't really find this one. So we have to use this because we're going to be solving for n. So let's set it up. We need u1, right? So for u1, you just plug in 1 right here. 1 minus 1 is 0. Times 4 is 0. So u1 is 7. You see that? And the difference is 4. That's the difference right there. It's the coefficient, right? So I'm going to set up this formula. So 663, that's the sum, is equal to n over 2. I don't know what n is. Times 2 times 7, that's 14. Plus n minus 1 times d, which is 4. All right. Now, remember when we had one earlier where this was 0 and we multiplied by the reciprocal? We don't really want to do that right now. So what I would prefer to do, what I think would be easier, is to multiply both sides by 2 to get rid of the fraction. And so this is going to be 1326 equals n, and then whatever's in here. So here's what I'm going to do. That's going to be 14 right here, right? And I'm going to distribute, so I'm going to get plus 4n minus 4. Yeah? These two right here make 10. So what I really have is I have n 4n plus 10 equals 1326, right? So we're going to just have to distribute this, and we're going to end up with a quadratic. Look what we're going to get. I'll write it over here. 1326 equals 4n squared plus 10n. And then when we move the 1326 over, we're going to get 4n squared plus 10n minus 1326. It's quadratic. I tried it already. It's not factorable. We're going to have to use the quadratic formula. You know that hotness, right? X equals negative b plus or minus b squared minus 4ac all over 2a. We're going to have to use that to solve this. So I'm going to run out of room right there. So I'm going to try that down here. So check this out. Negative 10 plus or minus. So we're going to get 100. And then, you know how it's minus 4ac? Well, I have minus 4 and then this minus right there. So that's going to become a plus. So I'm just going to go ahead and do plus. 4 times 4 is 16. 1326 all over 2a. A is 4, so over 8. And when you plug this into the calculator, it doesn't take that long. It can seem overwhelming, but let's see if we can get this set up right here so you can see it. So check this out. I'm going to do the radicand first, right? The discriminant. So 100 plus 16 times 1326 equals. And I'm going to take the square root of that. Right? Okay. And I know my answer has to be positive because n is a positive integer. So I'm not even going to worry about subtracting 10 from that, or making that a negative. So I'm going to have 136, right? Because it's going to be negative 10 plus that, right? divided by 8. And I made a typing error because the answer is 17. Let me see. Let me try this again. So I got 100 plus 16. Did I write down? No, I was just seeing if I had written something down wrong. So 100 times plus 16 times 1326. All right. Second square root, second answer. There we go, 146 minus 10 divided by 8, 17. I must have typed a number wrong. I don't know what it was. I don't know if you can hear my dogs playing in the background, but they are right underneath my feet. So, anyway, I don't know what I did right there. Let me see if I had... I'm just trying to find my mistake. I don't know what I did wrong. Anyway, 17, there we go. So, moral of the story. Sometimes you end up having to use stuff you haven't used for a while, and you've got to remember you're not going to get a prompt to do that. Okay, next up, find the expression below represents the sum of the arithmetic series, right? Find the number of terms, the first and last terms, and then the sum. So we have to find n, u1, un, and sn. Okay, so the number of terms, look at where we start. We start at 5 and we go to 12. So that's 8 terms because you've got 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. 8 terms. So n is 8. Okay, u sub 1. So when I find the first term right here, the first value to plug in is 5. So 5 times 2 is 10 minus 1. 9. The last term ends when we plug in a 12. So 12 times 2, 24, minus 1. I'm going to put 5 there. I don't know. 23. All right. Doing good so far? Those dogs are extremely helpful. Can you tell? All right. So, next up, we got all that. Now we got to find the sum. Hey, you guys go downstairs. Stop. Go on. They think it's dinner time. Sorry for the disturbance. All right. So we've got the first and we've got the last term. So I think this would be the easiest one to do. So we're going to do s sub 8. It's not 12. There's 8 terms. We're adding 8 terms. We're not adding 12 terms because we're starting on 5 and ending at 12. So, so 4, because 8 over 2 is 4. And then add these two up. 9 plus 23. That's 32 times 4. I think that's 128. And let me check that. That is correct. All right. So there we go. Almost done. This one right here, an arithmetic series has 12 terms. The last term 76, and the sum is 492. We need to find U1. Oh man, this is a little tricky right here. All right, 12 terms. So I know that has 12 terms. The last term, okay, there's the thing I was looking for. 76 and S12 is 492. All right, so that's actually this one right here. Because see, look, I need to find the first term. That's the thing I don't know. That's what I don't know. I do know this, and I do know this, and I do know that. So 492, see, 492 is S12 equals 6, because n is 12, right? Let's see, and then parentheses U1 plus UN, the 12th one. The last one is 76. Just trying to be careful right here. Okay, so we're going to divide 492, 82 equals U1 plus 76. So subtract 76. 6 is the first term. Okay, the last one is actually pretty tricky. And when I did this problem, I had to stop for a minute and really sit down and think because I wasn't really sure what to do. So let's dive into this last one right here. This is number 12. Okay, the third term of an arithmetic sequence is 14. So U3 is 14. And the sum of the first 20 terms is 710. Find the first term, and find the common difference. All right. Well, when I did this the first time, what I started with was just trying to figure out the sum, like this thing right here. So let's try that. So we've got S20. I don't know the common difference, so actually I'm going to use this one right here. So I don't know the common difference. Equals 20 over 2, that's 10, right? I know this is 710, times 2u1, we don't know u1, plus, let's see, 20 minus 1 is 19. I also don't know the common difference. So I got that right here, and of course this is 710. So let me rewrite that. 710 equals 10 times 2u1 plus 19d. Now, there's a problem because I have one equation and two variables. I can't solve that. And so the thing that was really tricky is I wasn't sure how to proceed. But then I remembered we also can use this formula because we have to find u1 and we have u3. We don't have the difference, but we can set up the formula. So watch this. So u3 equals u1 plus 3 minus 1 times d. And of course, u3 is 14. So 14 equals u1 plus 2d. So now I have two equations and two variables. I have a system of equations. I can solve that. So what I'm going to do is I'm going to solve for u1, and I'm going to take that, and I'm going to substitute it here. Do you see? So 14 minus 2d. So 710 equals 10 times 2 times u1. u1 is 14 minus 2d plus 19d. You see how that works? Right there? I just took and replaced u1 with that. All right, I'm going to divide by 10, so I'm going to get 71. I'm going to simplify this a little bit right here. I'm going to do it down here. So look, here's what I've got. I got 2 times 14 minus 2d, not 29, 2d plus 19d. So if I distribute, I get 28 minus 4d plus 19d. So that's going to be 28 plus 15d. We good? All right. So 28 plus 15d. So I can subtract. That's 43 equals 15d. So 43 over 15 is equal to d. Now I could make that into a decimal. I could do whatever with it. But I'm going to take this now, because this is our common difference, 43 over 15. I'm going to take that and plug it in here. So I have 14 minus 2 times 43 over 15 equals u1. Yeah? And then I guess I'll just use my calculator because it doesn't say to leave it as a fraction. So 2 times 43 divided by 15 equals, and 14 minus that. So u1 is going to be 8.2726 repeating, so I'm going to round it, right? And if you wanted to know that as a fraction or as a decimal, 2.87. There we go. So anyway, that's the whole homework. Took a little while, I know, but I hope this was helpful. If you were really stuck on a problem, you saw it, and you might feel good about it right now, my advice would be to take a little break, rewrite the problem without looking at the work, and then try it again on your own. All right. Hope you guys have a great day.